So today we see the evolution of cellular networks, starting from first generation to fourth generation. Uh, First of all, we see about that first generation. First generation refers to the generation of wireless telephone technologies, mobile telecommunication, which was first introduced in 1980s and completed in 1990s. At the starting of first generation, the speed is up to 2.4 kilobits per second, and it allows the voice call in one country, only in one countries. So here they are using the analog signals for transmission. The first technology they have named it as AMPS, that is Advanced Mobile Phone System, was first launched in USA in 1G mobile system. In first generation cellular system, advanced mobile phone services like invented at Bell Laboratories at 1982. The key ideas are exclusively analog. It is exclusively analog. Geographical areas are divided into cells. Typically, each cell has 10 to 25 kilometers, and cells are small. And they have implemented the frequency reuse concept, exploited in nearby. That is not used in nearby frequency reuse. And smaller cells also record less powerful, cheaper, and smaller devices. First we see that the technology used in first generation. So first generation analog system, which is introduced in North America, and see that bandwidth is 25 MHz bands are allocated to AMPS. Forward, that is forward base station to mobile unit is 869 to 894 MHz, and reverse up communication from mobile to base station 824 to 849 MHz. In each market, two operators are accommodated. So each operator is allotted to 12.5 MHz in each direction. The channel spacing is 30 kHz apart. Then each calls uses two traffic channels, forward equal to reverse plus 45 MHz. Then control channels are 10 kilobits per second digital channels. See that cellular structure is hexagonal, and we are dividing each cellular structure into hexagonal, and we are making it as geographical areas. We are dividing and clustering as 7 cell group, cluster of 7. Letters indicates frequency reuse, so which is not in the adjacent side. Frequency reuse is different logical geographical areas we are using. For each frequency, a buffer of 2 cells is used before reuse. So before reuse, we need a buffer of 2 cells. To add more users, smaller cells are used. So in major cities areas, we are using small cells. We are reducing the size cell areas. That is picocells or microcells. The frequency may not need to be different in CDMA. This is a cellular networks where we can communicate from the cell point to base station to mobile telephone switching center, and from the MTSC we are interconnecting with the public switched telephone networks. In the MTSC we have two register, that is home location register and visitor location register, where we are maintaining the database of call histories. So mobile users need to communicate with the base station, that is BTS, base transceiver station, and base transceiver station used to communicate with the MTSC, and MTSC is interconnected with the public switched telephone networks. And the wires are interconnected with the base station BTS with MTSC, and MTSC is interconnected with the PSTN. So drawback of 1G is we already know it is a poor voice quality, poor battery life, large phone size, then no security and all at that time, then limited capacity and poor handoff, that is called handoff from one cell to another cell. And then we discuss about the 2G technology. So 2G technology refers to the second generation based on GSM, that is Global System for Mobile Communication. It was launched in Finland in 1991. So 2G introduces the digital signals. Its data speed is up to 64 kilobits per second. Its features include multimedia messages, text messages, picture messages. It provides better quality and capacity of phone. So now we'll discuss about the GSM. What is GSM? Global System for Mobile Communication. It is in second generation. It provides voice and data services. So GSM services, we have tele services, data services, and supplementary services. In tele services, it includes mobile phone, emergency calling, etc. Data services provides SMS, fax, voice mail, electronic mail, etc. Supplementary services like incoming call, outgoing calls, call forwarding, call holding, call waiting, and conference call we can done using the GSM. Then at the same time they have introduced CDMA also. 2G CDMA is a code division multiplexes. We are dividing the channel into different channels, single channel to multiple channels, and we are accessing the codes for each channel. That is CDMA. Here the advantage of CDMA is frequency diversity. So frequency dependent transmission impairments have less effects on signals. Then multipath resistance. Then privacy is there. Then graceful degradation. System only gradually degrades as more users access. So degradation means what? Reducing the performance of system. So when it is degrading means a number of users increases, the degradation increases. This is a comparison of GSM and GSM and CDMA. So storage type is in GSM is SIM type and CDMA is internal type. CDMA which has no SIM type. Then major points like it has data transfer as GPRS we are using in GSM. Then CDMA using 3G, 4G, LTE. Then network type, you can see every cell has corresponding cell networks. Then CDMA has special code for every device. Already we have discussed that CDMA is a special code we are accessing for every device. Like GeoPhone we are having CDMA technology which has special code for each device. Not like GSM. GSM is a cellular tower networks technology. Then frequency band is different and the network service is SIM specific and it is handset specific. So drawback of 2G is requires strong digital signals to help mobile phone works. It requires strong digital and these systems are unable to handle complex data such as videos.